So, knowing more about potassium, we all know that every plant needs three basic elements to grow: nitrogen, phosphorus, and potassium, abbreviated as N, P, and K. So, specifically in our topic with potassium, why K? Sir Humphrey Davy. He discovered potassium in 1807 and gave it the Latin sounding name Kalium. Why Kalium? But most people stuck with potassium, which is derived from the term everyone already knew: potash, a common name for salts that contain potassium. The great thing about the word potash is that it is also a useful set of instructions on how to make potash. You get a pot, then soak wood ash in it. A piece of cake. Potash was originally used to make soap, bleach, and glass, but in the middle of the 19th century, it started to use as a fertilizer. Potassium is a very useful element in humans. It's key to help circulation, which is why we're often encouraged to eat potassium-rich foods like bananas. And just like potassium helps with circulation of fluid in the human body, it does the same thing for plants, and much more. In fact, when potassium is lacking in plants, the result is stunted growth, disease, or even worse, the plant just withers away. Potassium is a kind of regulator. It helps plants efficiently use water to transfer food and helps protect against stress. Like nitrogen and phosphorus, potassium is found naturally in soil that often there's not enough for plants to thrive, especially after years of growing crops on the same land. Hello everyone, my name is Karen Claire. I'm the woman. Today I will be presenting to you the topic potassium salts and mixed fertilizers. So this one's here a potassium cycle. Here we will look at the inputs of potassium to the soil and also the exports of potassium from the soil. So by knowing that minerals and bedrocks, as they wither, they release potassium and other nutrient fertilizers. So here in the parent materials or minerals, so bedrock minerals and such as feldspar and etc., it releases potassium over time in a very slow process. And so if this potassium are fixed or held by clay particles, this is what we call the non-exchangeable potassium as shown here. So it means that it gets trapped as the parent materials or minerals weather in clay layer. And here we can see here at the bottom, since this is in equilibrium with soil solution, this is called as the exchangeable potassium, meaning it can be immobilized by the soil itself. So this one's here is available to come into solution, build up plants, because this potassium here is held on the outside of clay particles rather than inside of clay particles. So we can also see here that some losses of potassium from the soil through erosion and runoff. And another one is it can be through leaching on sandy soils which have very low cation exchange capacity, and also we have in organic soils. So here's a brief history on how this is all about. First, it was mentioned earlier that in 1807 by Humphrey Davy, it's the first isolation of metallic potassium, and followed in 1869, which potash was first imported from Germany, and for over 45 years, this country furnished America and the rest of the world with potash. After the German salts become available, there was little interest in domestic production of potash until the First World War prevented its importation. So the federal, state, and commercial companies developed several sources of potash supply. So among these were limes from saline lakes in the west, calcine fermentation slopes, cement kiln dust, wood, and coal, cotton hull ashes, and many minerals of great varieties such as alunite, sluicite, green sand, feldspar, and shale. So when the end of the war came, imports from were resumed and domestic production fell. So since that time, the discovery of new deposits followed by new developmental methods of processing has caused a constant increase in the amount of quality of potash salts produced, and in competition with low-priced European imports. So here in 1941 and 1942, the United States produced its entire need of potash for the first time. And while in 1962, the International Minerals and Chemical Corporation struck rich deposits of potash in Saskatchewan, Canada. So according to the U.S. Geological Survey in 2019, it estimates the global annual potash production capacity was 61 million metric tons, while actual production for the year totaled 41 million metric tons. So world potash production is confined to only 12 countries, and it's dominated by Eastern Europe, rather, Belarus and Russia, and Canada, which together accounted for more than 60% of world production. The major potash producers are Nutrien and Mosaic Company in Canada, um, Uralkali in Russia, and in Belaruskali in Belarus. Potassium chlorides accounts for about 90 to 95% of world potash production.
Saskatchewan has one of the largest and richest potash deposits in the world. In Saskatchewan, this underground sea of potash lies diagonally across the province's southern plain, sloping deeper into the earth from the northwest to the southeast. Several layers of potash are mined at depths of more than 1.7 kilometers beneath the surface. Every year, Mosaic produces more than 8.9 million metric tons of potash. That's more than 14% of the world's supply.
So looking in this slide, so we can see that China is the largest consumer of potash, followed by Latin America and the United States. Few producing countries, much of the world is heavily dependent upon imports to satisfy potash requirements. So world trade in potash is very significant, accounting for more than 70% of world production during the past 5 years. So we can see here a flow sheet of potassium fertilizer overview. So potassium-bearing minerals are mined from underground ore deposits, salt lakes, and brines. Then the ore must be beneficiated and purified using dry and slurry processes. The majority of mined KCl is used for obtaining various grade fertilizers based on the particle size, which is granular, standard, fine, or soluble. So granular KCl is often applied in mixtures with N and P base fertilizers to provide in one application the nutrients required by the crop. Potassium chloride, it is a metal halide salt composed of potassium and chlorine. The solid dissolves readily in water and is solution have a salt-like taste. It is used as a de-icing agent, fertilizer, flux agent for casting metal casting flux, pH buffer, corrosive flux agent. Also, it is used to prevent or to treat low blood levels of potassium or hypokalemia. So here is an abrupt discussion of the Trona flow chart. So first, let's take a look in this not so complicated procedure. So we have seen here that it produces borax, KCl, soda ash, and not only even these three outputs, we have many more. It will be discussed here the unit operations that undergoes potash and refined borax, and also the soda ash. First, here in the soda products, we have soda ash. It undergoes the barometric condenser, and then in the separator, going to evaporator to heat exchanger. So this happens 3 times until it passed through the salt separators, where the salt are then separated. It's filtered using vacuum filter. The liquors undergo in the clarifier, where it is produced, then it's filtered, and then we see that our soda products at the bottom are in its solid forms already. Next, in the potash production, from vacuum crystallizers, separators, barometric condenser, and also down to heat exchanger, here we see our liquor that it's already centrifugated. And here in the settler, it will be shown here that the decanted liquor will be produced here. So then our decanted liquor will be dried, and our potash will undergo bagging for shipping. In the crude borax section, first it will undergo refrigeration, and we will see that our crystals will be thickened already using the thickener. And then these thickened crystals are filtered, washed, and then in the vacuum filters, we see our final product, which is the crude borax that is refined. So, how did it all started? Do you want to know how it all started? Do you want to know the story of Trona in San Bernardino, California? I know it's very confusing here, so let's see an actual video on how this is processed, specifically in our topic, potassium. So potash is primarily used as an agricultural fertilizer. It is extracted from beneath the ground by conventional mining or by injecting hot brine which dissolves the potash and crystal salts. The solution is then pumped back to the structure where the potash is separated out in settling ponds. Potash is potassium chloride, a compound with a chemical composition KCl. It can be processed a granular agricultural fertilizer or into high-grade product for industrial use. So at this Canadian potash mine, the ore deposits like a kilometer underground. So the ore is comprised of three materials, which is potassium chloride, clay, and sodium chloride, better known as salt. A machine known as a continuous miner is used to cut into the rock face. It has two rotors, each with three arms. Each arm has 6 pairs of pits tipped with ultra-strong carbide that bite into the rock flake of the ore. The rotor arms sweep the ore into the machine, which feed it through a series of conveyor belts. Yes, there. Sheets of polymer fastened to the rock above direct the flow of fresh air that's pumped down into the mine to have ventilated. The ore is gradually transferred away from the rock face by the network of conveyors. At this potash mine, 10 machines work simultaneously at different locations. Their conveyors, which total 35 kilometers of moving belts, converge at the skip. So a giant elevator bucket which hoists up to 45 tons of ore at a time to the surface and dumps into a storage bin. Another conveyor now transfers the ore to the mill for processing. At the mill, the ore first tumbles down a series of vibrating screens. Smaller particles drop through the openings and move on to the next station, while larger particles stay on the top where a flow of brine washes them into a crusher. The finest particles flow to the fine flotation tank, while the larger ones sink to the bottom before draining out and traveling to the coarse flotation tank. Both sets of particles are now treated with chemicals. So over 5 minutes, the chemical treatment makes the potassium chloride particles attached to air bubbles and rise to the surface. In the coarse flotation tank, paddles skim the surface, pushing the floating potassium chloride into a collector. The clay and salt particles are drained from the other end of the tank. Similarly, in the fine flotation unit, the potassium chloride particles attach to air bubbles and rise to the top where they overflow into a collector. The potash that's been collected then passes through a centrifuge and a dryer. This will be to remove any moisture. The dryer feeds a vibrating screening machine which separates the potassium chloride particles into 3 categories. One, which is oversized particles, or sent back to the crusher. 2 undersized particles are sent to machines which compact them into boards before breaking the boards into new particles, which is sent back to the vibrating machine for another round of screening. Yes, so particles of the correct size of the final product are transferred to the shipping warehouse. This granular potash will be used as a agricultural fertilizer. So it's comprised of 95% potassium chloride along with some residual clay and salt. Samples are regularly tested to confirm the potassium chloride content. So to do this, each sample is ground into a fine powder and compressed inside a stainless steel cap to form a pellet. The pellets is then loaded into an X-ray fluorescence analyzer. So the sample first absorbs energy and releases it as fluorescent radiation. The analyzer measures the fluorescence to determine the sample's concentration of potassium chloride. The mill also processes potash for industrial use. So this higher grade potash with potassium chloride concentration of 99% is a white powder. This is made by dissolving 95% potassium chloride in hot brine to remove more of the residual salt in clay. The potash is then crystallized by evaporation and cooling to leave the potash that's almost pure potassium chloride. In the manufacturing of sylvanite in 1925, potash was discovered at Carlsbad, Mexico. After much prospecting and drilling, a shaft to mine the mineral was sunk to about 1,000 feet. In 1932, a refinery was constructed, and now the largest proportion of the supply of potassium chloride for the United States is being produced here. The ore is sylvanite, which is the accepted term for the natural mixture of sylvite, KCl, with halite, NaCl. So, for a better understanding of this diagram, let's present it this way. So, here are the raw materials of manufacturing sylvanite, NaCl, and KCl. So, here's the basic flow sheet of manufacturing sylvanite. So, here in the crusher, we see a flow of ore that is crushed into a 4-mesh particle size, and that it is then passed through a measuring bin and also to the dissolver. So yes, it is shown here that in the dissolver from the settler, the hot water liquor is passed through a series of steam heated turbo mixer, and that it dissolves counter current to a flow of the ore here. So this is moved in a dissolver by a mechanical elevating equipment. So here in the dissolution process, the cold water liquor is heated to 100 degrees Celsius. And so, potassium chloride goes into solution together with a small amount of NaCl. So now the enriched mother liquor passes through a thickener equipment where the insoluble mud is settled out. So the underflow mud is washed by countercurrent decantation in a tray thickener, while the hot, clear, saturated overflow solution is pumped to vacuum coolers and crystallizers. So here in the settler, we have the mother liquor also mother liquor and the crystals rather. So what's happening here in the settler is that in the settler it passes through a filter, and that also the dissolver via series of steam heated turbo mixers. So on the other hand, tailings from this process, largely NaCl, after passing through centrifuges where adhering potash bearing brine is removed, are carried out to the plant to waste storage. So vacuums in the coolers and crystallizers is maintained by means of steam ejectors. So also in these vessels, the solution is cooled to 27 degrees Celsius, and the potassium chloride falls out the solution and in suspension is pumped to settling tanks, where a large part of the liquor is decanted through landers to be used again. So the dried cake is crushed, screened, and conveyed either to warehouse or to cars. So mineral processing of potash and rock salt ores involves flotation of the crushed salt ore. The flotation technique aims to concentrate the salt minerals and to reject the gangue phases. Alternatively, dissolution of the entire crude salt occurs by hot aqueous solutions, and the salts are precipitated. So, consequently, potash and rock salt mining produces very little mining waste, whereas mineral processing results in the rejection of the majority of the mined ore as liquid and solid wastes. So, in particular, potash ores generates more waste than any other salt ores. The major waste products of potash and rock salt processing includes these ones here, the brine and tailings. Proceeding with various potassium salts, we have first the potassium sulfate. Prior to 1939, the German potash industry was the chief source of potassium sulfate for American chemical and fertilizer industries. Although considerable tonnages were being produced in this country by the interaction of potassium chloride and sulfuric acid as a side product of salt cake manufacture. Recently, the Potash Company of America inaugurated a modified Hargreaves process where potash will be reacted with sulfur dioxide, air, and steam to yield potassium sulfate. In its agricultural use, potassium sulfate is preferred for the tobacco crop of the southeast and for citrus crop of Southern California. Next one's here, the potassium hydroxide and potassium carbonate. So these two are very closely related. Some years ago, most of the potassium chloride was made from potassium. And also the carbonate is by made of the reaction with calcium hydroxide. But the production of potassium hydroxide by electrolysis of potassium chloride solutions has led to the production of potassium carbonate from potassium hydroxide. In industry, about 34 million pounds of caustic potash are consumed per year in the soap, detergent, and dye fields. On the other hand, the potassium carbonate, like the caustic, is used mainly for soap and chemicals and is consumed about 36 million pounds per year, and it is the preferred source of potash in the glass industry. Potassium nitrate. This salt is made by the double decomposition reaction of sodium nitrate and potassium chloride with a delta H of positive 3,160 calories. A strong hot solution of the sodium nitrate is made and the solid potassium chloride is dumped into the kettle. So, upon heating, the KCl changes to NaCl, whereupon the hot potassium nitrate solution is run through the NaCl crystals in the bottom of the kettle. A little amount of water is added to prevent any further deposition of NaCl, and the solution is cooled, and then there, a good yield of potassium nitrate is the result. So, potassium nitrate is frequently referred to as an essential in the manufacture of slow-burning black powder, which is used in fuses in the ignition of smokeless powder and also in the manufacture of pyrotechnics and glass. Potassium acid tartrate. This one's a byproduct of winemaking, and in cooking, this is known as the cream of tartar. At the present time of domestic tartrate industry is being developed by processing pomace, which is the discarded mass from wine fermenters and contain from 1 to 4% potassium bitartrate. Its greater part of the supply is imported crude argols from wine vats. The pure salt is obtained from the argols by leaching and crystallizing. So, it is mainly used as the acid ingredient of baking powder for the preparation of tartaric acid and in medicine. Potassium peroxide. So, this is formed as potassium reacts with oxygen in the air along with potassium oxide K2O and potassium superoxide KO2. So, a short trivia for this one. Here's this journal somewhat published many years ago entitled Hydrogen Peroxide for Propulsive Power Production and Use by the Germans during World War II. So, during the Second World War, a reaction using sodium and caustic potash was employed, and that the larger proportion of the potassium made is used to produce KO2, which is used in protective breathing equipment. What this does is that KO2 reacts with the expelled breath to liberate oxygen and remove CO2 and H2O in the so-called rebreather gas mask. And by knowing that, some potassium is used to make other alloy of sodium and potassium, which is a liquid at room temperature. Here in the mixed fertilizers, we have basically we have three types of fertilizers. First, we have straight fertilizers. This means that out of three primary nutrients of soil or crop, one is present in that fertilizer. Either N, P, or K is present in that fertilizer. For example, ammonium sulfate, ammonium nitrate, and urea. These fertilizers contain only nitrogen as a nutrient. The second one, we have complex fertilizers. This means that two or three primary nutrients are present in the chemical combination. Example, we have diammonium phosphate in this fertilizer, nitrogen and phosphate in a chemical combination. The third one, we have the mixed fertilizers. Here, the physical mixtures of straight fertilizers is prepared and use a mixed fertilizer.
Crops depend on nutrients found in the soil, but the nutrients in the soil varies with diverse locations, while different crops are in need of many nutrients. Atlas Fertilizer Corporation is dedicated in solving this through creating crop-specific, soil-specific fertilizers, giving healthier crops, increase in yield, and generates more income. Atlas Fertilizer Corporation has been providing farmers a better harvest for 60 years now, which has led Atlas Fertilizer Corporation to become the country's leader in crop-specific, soil-specific fertilization technology. This is achieved through years of in-depth laboratory research and development, pilot plant production, and vigorous field trials strategically deployed nationwide. Atlas is continually engaging in further study through partnership with reputable research institutions. finding new and better practices in fertilization technology, which also led to the development of the Atlas Rice Crop Manager, which provides farmers with personalized crop and nutrient management guidelines. This is implemented through their partnership with government institutions, providing aid to farmers with farming technology and marketing trainings. Today, Atlas continuously innovates and improves to continuously contribute to Philippine agriculture through quality fertilizers.
So the mixed fertilizers are categorized on the basis of grades, and the grades indicates NPK. It means the quantity of NPK supplied by these fertilizers refers to the minimum guarantee with regard to the nutrient content of the fertilizer mixtures in terms of NPK. Here, nitrogen is present as percentage by weight, phosphorus is present as P2O5 by weight, and potassium is present water-soluble potash as K2O percentage by weight. For example, NPK is available in proportion 12:32:16. Its nitrogen content is 12% by weight, phosphorus content is 32% by weight, and potassium content is 16% by weight. Here we have the complete fertilizers, which have all the three of the primary elements. Now, note that complete fertilizers does not mean that all 14 minerals nutrients are included. To determine the amount of each nutrient in a complete fertilizer, the percentage of the nutrient is multiplied by the weight of the fertilizer. For example, in a 50 pound of bags of 20-10-20, the amount of nitrogen equals 10 pounds of the bag, 5 pounds of the phosphate, and 10 pounds of the potash as seen in the calculation on the slide. Fertilizers grades never total 100%. For example, 10-10-10 fertilizer is 30% nutrients and 70% other ingredients. So, what are those other ingredients? Primarily, the remainder of the fertilizer is the weight of the other elements that are part of the carrier, such as hydrogen and oxygen. A small percentage is fertilizer filler, and conditioner fillers may be sand, clay granules, ground limestone, or ground corn cob. Fertilizer ratio states that relative amounts of nitrogen, phosphate, and potash in fertilizers. Ratios are useful when comparing to fertilizers as shown in the following examples. Note that A and B have the same ratio. This means that one fertilizer can be used in the place of the other. Applying 1 ton of 10-10-10 is the same as applying a half ton of 20-20-20. One way fertilizer grade is listed leads to some confusion. Some people think of fertilizer grade as NPK. Actually, nitrogen is listed in the element, but the other two nutrients are listed in their oxide forms. The true grade should be listed as NP2O5K2O, which is read as nitrogen, phosphoric acid, and potash. As an example of this confusion, consider the fertilizer 20-10-10. The numbers lead to expect 200 pounds of phosphorus in a ton of this fertilizer. So, to determine how much actual potassium is contained in 1 ton of 0060, it would be 2000 times 60% divided by 1000 times 0.8, which equals to 996. In this table, we see crops take up far more potassium than they remove with the harvested portion. Crops harvested in which the whole plant is removed from the field, like alfalfa hay, must have more potash applied than crops where only grain, lint, or fruit are removed. So often with hay and silage crops, removal is an excellent guide for planning the potash fertilization program. With other crops, such as grain, soil test offers the best guide. For nitrogen constituents, we have in the form of ammonia, ammonium salts, nitrates, and organic nitrogenous materials. Nitrogenous compounds stimulates the vegetative growth in plants through nitrogen-containing proteins and chlorophyll. A little overview in the phosphate fertilizing constituents. In the superphosphate, overview of superphosphate fertilizer, it contains 40 to 45% available P2O5 for plants. This is when phosphate rock is treated with phosphoric acid instead of sulfuric acid. This is the manufacturing of triple superphosphate. So as shown here on the flow diagram, the phosphoric acid is preheated in a acid preheater and fall to a granulator with phosphate rock and water. It is also supplied with a steam. So in the granulator, the reaction takes place to produce the triple superphosphate, and the hydrofluoric acid is sent to the top of the wet scrubber. Here, the hydrofluoric acid vapors are washed with the help of water, and the remaining gases, which are free from hydrofluoric acid, are released to the atmosphere after proper treatment. The main product, which is triple superphosphate, is cooled in a cooler, and the fine particles that are unreacted material is sent to a cyclone separator, where the fine particles are removed from the top of the cyclone separator and the bottom is recycled back and fall to a granulator. The product triple superphosphate from the cooler is screened. The coarse material is again recycled back and fall to a granulator, while fine materials is stored in a bulk storage, which is directly for shipping. Potassium salts in the forms of nitrates, sulfates, and chlorides are the forms of potash used in fertilizer. They get used by plants that then release potassium into their crops, and it is essential for water uptake and for synthesizing plants' sugars for use as food. So that's it for potassium salts and mixed fertilizers. Thank you for listening.